welcome back to Miss Nell Speaks. So we are going to learn composite function today, a continuation of functions from the first part of functions that we learned in the previous lesson. So imagine if you have a domain X that is mapped onto the domain Y, codomain Y, using a function fx, and then followed by another set of domain Y being mapped onto the codomain Z using a function known as gx. So this is a continuous function, or it's made up of two different functions. Hence, the entire function here will be known as the composite function. So we are going to learn how to find the composite function of two functions today. So imagine you have a function fx which is equals to 4x and another function gx which is equals to x plus 2. You want to find the composite function of fg. So how do you actually find the composite function of fg? Always do the one that is closer to the x. So the function that is closer to the x is actually the function g. So we're going to substitute wherever you see g with its original function, because the function of g is actually x plus 2, right? And then now, if you could remember back the first part of function where we learned how to actually substitute different domains, and now the domain is x plus 2. So everywhere that you see x plus 2, you will put it into the x, because the original of function fx is equals to 4x. So therefore you're going to have 4 multiply x plus 2, and expanding the bracket will give you 4x plus 8. Okay, let's try another composite function now. Instead of finding fg, let's find gf. So if you can still remember, we always start with the alphabet that is right next to the x, and the alphabet that is right next to the x is actually f. So we are going to substitute whatever we see into the f, and we know that the function fx is equals to 4x. So wherever you see x now, because the function of gx is equals to x plus 2, so you're going to substitute the x with 4x and add it up with 2, and there you go, the answer is 4x plus 2. Alright, let's look at another example. So in this example, we're going to have 3 functions, because I would like to actually compose different types of functions together. The first one, fx equals to 2x plus 3, gx equals to 5 over x, and hx equals to 1 minus x squared. So we're going to try the first question. Let's start out with fgx, and which is the first function that we need to substitute, the one that is closest to the x. In this case, that will be gx. So let's substitute gx with into the f gx, and that gives you f 5 over x. So wherever you see x in the f, you are going to put in 5 over x. So we try and expand wherever we can. You can leave your answer like that as well. Okay, moving up. Next, let's look at another question. Maybe we try hfx. Okay, so again, the one that is closest to the x is f. So you are going to actually do the f first. So put inside the f, that will give you 2x plus 3. And now you are going to actually put the entire 2x plus 3 as the x in the hx. And that gives you 1 minus 2x plus 3 bracket square. So we have to actually expand this brackets So if you guys do remember, and expanding the bracket and simplifying everything will give you the final answer is negative 4x squared minus 12x minus 8. Okay, now let's try GHX. Another question. So the h is right next to the x now. We're going to start off with the h. So we're going to substitute 1 minus x squared because hx is equals to 1 minus x squared. And then you're going to put inside the g, which is 5 over x, and in this case it will be 5 over 1 minus x squared. So there you go, few examples on composite function. Again, hopefully you have managed to try some of the questions, and see you again. Bye bye.